Hello, this is Professor Urbis. Today we will talk about simplifying radical expressions. Okay, the first thing you need to know is the product rule. Just remember it. If you have a radical expression, you can split it. Okay, here's a catch. If you have different indices, you cannot split them and then kind of try to figure out what the heck that is. So in other words, you can do this. Let's say x, y. You can split it, x and y. But if you have, let's say, cube root and then square root, and you cannot write, oh, this is x and y. Oh, well, I'm not quite sure about that index is. And actually, you can do that, but it is not 3 or it's not 2. Okay? So you have to be careful with that. Other than that, you can split them when the indices are the same. So remember that. Okay. That's going to be pretty handy in doing simplifications. So if, let's say, they are giving me something with a bunch of letters and numbers, and then they're asking me, just simplify. All right, so the first thing you do is you look at the numbers, and then you prime factor them. Okay, so let's do that. Divide by 2, you have 32. 2 times 32 is 64. Divide by 2, you have 16. Divide by 2, you have 8. Divide by 2, you have 4. Divide by 2, you have 2. All right, then you go and you write 6 root of 1, 2, 3, 4, 5, 6. Oh, look at that. 2 to the 6th power. Now, I try to write each one of these guys as a power of 6. And if it is not going evenly, then I will actually go and then write the leftovers. I'll just show you. X to the 12th is actually x to the 2 to the power 6. Does that make sense? Because 6 times 2 is 12. Let's try y. Okay, can I write this as a power of 6? So let's look at that. 4 times 6 is 24. That's too big. 3 times 6, that's 18. That's good. 3 times 6 is 18. Then how do I get from 18 to 23? 18 to 20, that's 2 to 23. So I have a leftover y to the 5th. Do you understand that? All right, good. So I took care of the y's. Z. Okay, divisible by 60. All right, let's think about how that goes. I have 6 times 8. That's 48. And then to 50, so that is 2. So what I do is I write everything as power of 6 so that I can take things out. If this was power of 5, then you write everything as a power of 5 inside the radical sign. Now, let's take things out. This comes out as 2. This comes out as x to the 2nd. This comes out as y to the 3rd. So I took care of this, this, this. This is behind. This comes out as 8. And what do I have left behind? 2. Does it make sense? So you have 2 x squared y cubed z to the 8 times 6 root of y to the 5th times z to the 2nd power. Very good. So, and one thing that we do is we assume all variables are positive, so we don't have to worry about absolute values. Okay. Now, how do I do the same problem using the radical exponents? Remember, we do the same thing. 232, 216, 28, 24, 22. So we do this again. But this time, what you're going to do is you're going to write this as an exponent instead of using it as a radical. This is the second approach. So instead of 64, I'm going to write 2, 1, 2, 3, 4, 5, 6 power. All right? This one, I'm not going to worry about grouping them into 6s and stuff. I just write it. And this one, I just write it. And this one, I just write it. But I'm going to take them out of the radical, and I'm going to write it as 1/6. All right. Do you remember the rule that I can split things? So I'm going to just split things. This one is 2 to the 6th power to the 1/6. X to the 12th power to the 1/6. Y to the 23rd power to the 1/6. Z to the 50th power to the 1/6. All right. So what is this? 2 to the 6th power to the 1/6. That means 2 to the 6 times 1/6. Guess what that is? That's 2. All right? Because these 2 will cancel out. It'll give you 1. X to the 12 times 1/6. What is that? 12 times 1/6. That is 12 divided by 6. That's 2. Now, I'm going to do y. Y to the, this one is 23 over 6. You know what? I'm going to go to the side and deal with those improper fractions. 23 over 6 is simply if you have 3 and 5/6. Is that right? 3 times 6 is 18 plus 5, 23. Okay, so I have to be careful with that one. So this is actually y to the 3rd and y to the 5/6. I split them. How about z? Z to the 50 over 6. Well, let's go to the side and figure out what the heck the 50 over 6 is. 50 over 6, 6 times 8, that's 48, 2 over 6. All right? So what does that mean? Z to the, z to the 8 and z to the 2 over 6. All right? So let's write it nice and pretty. What do I have? You have 2, you have x squared, you have y cubed, and you have 5/6. So that means I'm going to have this in there. So that's going to stay inside the radical. Then I have z8. All right? And then what do I have here? Z to the 2nd. And here's your final product. And that happens to be the same exact thing that we got, 2y squared y cubed, 2x squared y cubed z to the 8, 6th root of y to the 5th, and z squared. So it happens to be the same exact thing, but what did I do? I just used the exponent approach. Same problem. All right. So I just actually want to go through this. What happens when you have different indices? I actually typed this up for you. What you do is, I go to the exponent notation. It's a little bit easier. So write everything as 64 is going to be, remember what that was? It was 2 to the 6th power, x to the 12th power, to the 1/6. And I write this as an exponent notation, 2x squared to the 1/3. And let's look at that. Now, instead of what I try to do, I try to match the denominators. So multiply top and bottom by 2. So I have 6 and 6 right here. Now what am I going to do? So I'm going to put these two together and in one big happy family and in the 1/6 power. So you have 2 to the 6th, x to the 12th, and what is this? It's 2x squared square. Now open this up, 2 to the 6th, x to the 12th, 2 squared is 2 squared, x to the 4th. Now let's put these two together. You're going to have 6 plus 2, that's 8. This is 12 plus 4, that's 16. Now work this in. Then you're going to get 2 to the 8 over 6, x to the 16 over 6. 8 over 6 is 1 and 2/6. I'm doing the exponent approach. And 16 over 6 is 2 and 4/6. What does that mean? That 2 to the 1st can come out, x to the 2nd can come out. Do you see these whole parts? Okay, here it is. And what do you have left? 2 to the 2/6, which is 1/3, x to the 4/6, which is 2/3. What does that mean? 2x squared. You have 2x squared, so this is 2, and then you have x squared and to the 3rd root. You see, you're just kind of putting it all together. Okay. Now, if I want to use the quotient rule, I can split them as well. And remember, you cannot split them when they are different indices, just like we did in the product rule. So let's see what we can do with the quotient rule. So I'm just going to assume again all variables are positive, and we're going to prime factor 2 and 5. This one is 3 and 27, 3 and 9, 3 and 3. So you prime factor, and we go and we write them out. So I'm going to write this thing right here. I have fourth root. 10 is 2 times 5. This one is x to the fourth. Now I have y to the just 1, and then you have 81. 81 is 3, 3, 3, 3. 3 to the fourth power, and then you have an x to the negative 8. So let me put another paper underneath so I can write. Here we go. Now what I'm going to do is I'm going to move that negative exponent up. So I have fourth. So you have 2, 5, x to the 8 goes up. That becomes 12. Y to the 7. And 3 to the fourth. So let's take things out that I can take out. 2, 5, hopeless. I can't do it. Now let's take this guy out. That comes out as 3. Let's take this out. 12 divided by 4. That is also 3. Okay? Now what's left behind? You're going to have a 2 and a 5. This came out already. 7. That one is behind, okay? So let's look at that. What do I have? Oh, this is not a 7. It's just 1. So that's fine. So I leave that y behind. So let's make it pretty. X cubed over 3. Fourth root of 2 times 5, 10y. So this is actually my final product. Do you see that? Okay, very good. Now, if I want to use the exponents, I do the same thing, but this time I'm going to put it so using the exponents, I'm going to put it in the exponent form. So we did the prime factoring already, so let's do it again. So this is 2 times 5, this one is 3 times 3 times 3 times 3. So I'm going to write everything that way as a power. So let's go to the 1/4 power. So I have 2 times 5, x to the fourth, y, and this one is 3 to the fourth. And I'm going to move that x up, x to the 8. Okay, so let's write this. So I'm going to go and move that in. So I have 2 to the 1/4, 5 to the 1/4. This one is 8 plus 4, that's 12. X to the 12/4, y to the 1/4. And what's at the bottom? 3 to the 4th to the 1/4. Okay, when you work the exponents in and it kind of falls out, look how that works. 2 to the 1/4, 1/4, and this one is x, 12 over 4, that's 3, and nothing I can do about this one, and this one is 4 times 1/4, that's 3. So let's make it pretty. You have x cubed, which is this guy, over 3, which is this guy, and then I have what is left behind. You're going to have 2 and 5, so that's 10. This takes care of that, and then you have a y. You see, it is the same answer. So, regardless of if you are using the radical method or the exponent method, you can actually do the simplification and get the same answer if you're careful.